Okay, so the slope formula. In the last lesson, we talked about us not always being provided a graph in order to find the slope of a line, to find that speed, that velocity of that line. Um, and this is the lesson where we figure out how to calculate it mathematically. Okay, this is going to be page 33 in your binder. Yay, it's cooperating today. So it says use the graph at the right to answer A through D. It says A, what is the difference or the change in the Y values from S to T? Okay, well, we know that difference mathematically means to subtract, minus. Nice. There we go, subtract. Change in the Y values. So from S to T, the Y value in S is, if it will let me scroll over, the Y value in S is 9 and the Y value in T is 3. So when we subtract 9 minus 3, we get 6. Okay. Part B, what is the difference or the change in the X values from S to T? Well, the X value for S is 6. The X value for T is 2. So 6 minus 2 is 4. Okay. Now it says write the ratio of the change in the Y values, part A, over the change in the X values. Well, the change in the Y values was 6. The change in the X values was 4. With every good fraction, with any and every fraction, you always want to reduce or simplify. That gives us 3 over 2. Now compare that ratio, compare that fraction. Ratio is just another word for a fraction. Compare that fraction with rise over run. Let's see what would happen when we use rise over run. So we rise 1, 2, 3, 4, 5, 6. Okay. And then we run 1, 2, 3, 4, positive. And we already know that 6 over 4 is going to give us 3 halves. So what happened? The ratios are the same. Okay. We can describe the slope using with the following ratios. You can use rise over run or the change in y over the change in x, which yesterday or the lesson before this one, we wrote it down as change in y over the change in x. Okay, because of these ratios, the formula for slope is y2 minus y1 is over x2 minus x1. Okay, we take the y value of the second point minus the y value of the first point, the x value of the second point minus x value of the first point, which is what we did over here in parts A and B. Okay. And here you can see it in side by side, rise over run versus y2 minus y1. Okay. So it says use the slope formula to find the rate of change for each question below. Make sure to show all of your work. Okay. The reason I like, or one good thing about the slope formula is that even though you're given a whole table, you don't have to use every single point. All you need is 2. Okay, so I'm just gonna pick any 2 random points, the first and the last one. Well, this is the very first point in the table, so we're gonna label this one as our x1, y1. The one here, it doesn't do anything. It's just a label. It's a name and it just represents the first point. So we're going to put a little 2 here to represent the second point. Okay. We plug it into our formula. Our formula states that we need to subtract the second minus the first, second minus the first. So our y2, our second y value is 27 minus 3. Okay. And our x values, our second one is 3 minus 0. Good thing about this one, same thing with everything else that we've been doing this year. You can just put in the calculator. You don't have to make it more complicated than it is. So our slope is 8. Okay. Number 2, a line that passes through the 2 points, through these specific 2 points. Now, this one, they actually give us points to use. So I guess that makes it even easier for us. Because this is the first point that they give us, we'll label it as x1, y1. And we will label this one as x2, y2. So for our formula, first we subtract the y values. 2 minus 1, second minus the first one. So -4 minus what? -3. This is where some students are going to make some mistakes. Just make sure that you understand that that negative does not take place of the minus sign, okay? So it's still going to be -4 minus -3. Now, yes, we do have a minus and a negative next to each other. This is the only lesson where I allow you guys to have a minus and a negative next to each other. And the only reason is because the calculator will do the calculations for you. So we can avoid mistakes that way. Okay. All right. And for the next one, for our x values, x2 minus x1. So 3 minus -7. 3 minus -7. Okay. So we type that into our calculator. -4 minus -3. 3 minus -7. And we get -1/10 for our slope. Number 3. We use the 2 on the end, so this time I'm going to choose to use the 2 in the middle. Okay, so this is our first x value, second x value. Why did I do that? First y value, second y value. Okay, make sure you do it in the same order. You can't do 1, 2, then 2, 1. Okay, has to be in the same order. So 2 minus 1, 2 minus 1. -6.5 minus -8. And on the bottom, 2 minus 1, 6 minus 6 minus 4. Type it in the calculator. -6.5 minus -8. 6 minus 4. And we get 0.75. Yes, you can leave it as a decimal. This one, a line that passes through the origin in 6, 7. They only give us 1 point, but we do know something about the origin. The origin is point what? 0, 0. So here's our x1, y1, x2, y2. Try to zoom in some. And you always do 2 minus 1. So 7 minus 0. a place that whenever we're first learning this, one spot where I see a lot of students make mistakes is that they want to put the x values at the top. So make sure you're always double checking that formula. Your y values go first, then your x values. Just like rise over run, it's y over x. Everything with slope is y over x. All right, and then 6 minus 0, which 7 minus 0, 6 minus 0, when we know will stay as 7 over 6. Turn the page. How would we see these questions in a star setting? Let's look at number 5. A graph line contains these points shown in the table. What is the slope of the line? Well, this one actually asks us outright, what is the slope of the line? I'm actually going to just use the first 2 points. Nice. Just what I wanted. Big old line straight through everything. There we go. So x1, x2, y1, y2. These are my y values. These are my x values. There's an x there, right? So to find the slope, it's y2 minus y1. So 710 minus 360. And then 20 minus 10. Put that in your calculator. 710 minus 360. 20 minus 10. And we get 35. Whole number answer. Number 6, a graph line contains these 2 points. Find the slope of the line. Okay. x1, y1, x2, y2. All right, so we're going to do 2 minus 1, 2 minus 1, right? So that's going to be 2 minus what? Negative 9. Be careful with those negative numbers. And then 5 minus 5. What happens when you type this one into the calculator? 2 minus negative 9. I put too many negatives. 5 minus 5. We get an error. Why is that? Well, 2 minus negative 9. Let's work this out by hand. 2 negatives make a what? Positive. So that forces us to add 2 plus 9, which is 11. But 5 minus 5 gives us 0. What happens here? We can't divide by 0. And if it would let me write it, that would be even better. Can't divide by 0. Okay. So because we cannot divide by 0, what does that mean? That our answer is actually undefined. Undefined. So it says describe what the graph would look like. Well, whenever we think of undefined, you should be thinking Vux, right? So what would the line look like? It would be a vertical line that has an undefined slope. And its equation is x equals 5. X equals a number. But if you notice, the number 5 is the x value for both points. So it's always going to equal 5. Okay. Number 7. Tropical storm Ava brought heavy rain to Galveston, Texas. The table shows the linear relationship between the total inches of rainfall and time in hours. Calculate what? The rate of change. Calculate the rate of change. So we can use any random points. I'm just going to use these two. x1, x2. When your table is laying down, just keep in mind x value is on top, y value is on the bottom. Okay. Two minus one, so 18 minus 9. Then the x value is 24 minus 12. This would give us 18 minus 9, 3/4. You put it in the calculator. We do it by hand, then we have to continue to simplify. So 18 minus 9, just in case you don't believe me, 24 minus 12, you get 3/4. Okay. So the rate of change of rainfall per hour, how would we describe it in words? 3 is your y value, remember? Change in y over change in x. So the top number describes your y values. So it's 3 inches. Put the word per in there, 3 inches per 4 hours. Three inches per 4 hours. You could also say 3 inches every 4 hours, 3 inches each 4 hours. Either way. Last year we skipped over number 8, so I'm going to skip over it again. Number 9. Marco's growing crystals for an experiment. He has 2 jars containing different solutions to form the crystals. The tables show the linear relationship between the amount of crystal growth in grams and the number of days that have passed. Which jar has a greater rate of change? We want to know which one has a bigger slope. So we got to compare jar A to jar B. Okay, so for jar A, I figure we can just use the top 2. Trying to move over, it won't let me. All right, so y2 minus y1, 43.5 minus 29, and 6 minus 4. Put that into your calculator. $43.5 minus 29, 6 minus 4, and you get 7.25. All right, let's try jar B. This is our x1, x2, y1, y2. So for jar B, at the top, we're going to have 37 minus 22.2. And 5 minus 3. All right, so 37 minus 22.2, 5 minus 3, you get 7.4. So which one has the greatest? Jar B. Jar B has the biggest number. All right, use the graph to answer A through C. Explain the method you would choose to find the slope of the line. Not the shape of the line, find the slope of the line. That's supposed to say slope. Probably Microsoft Word probably just fixed that for me. Which method would you use? You're given 2 points, so you could use slope formula. But remember, if you're provided a graph, the easiest thing to use is rise over run. So let's find the slope of this graph. Draw your right triangle on top. We rise by 2. We run backwards, so that's 1, 2, 3, 4, 5. And we get 2 over -5. Wait, what? Oh, I messed up. Why did I mess up? Because I failed to notice that that was right there in the middle, but it's at 4.5. So that means it went up by 2.5. Now, when I simplify that, 2.5 over -5, I get -1/2. Okay. Now, it says describe the situations when slope formula would be more helpful than use counting rise over run. Well, the only reason that using rise over run was okay with this example is because it actually tells you that it is at 0.5. You don't always assume, you cannot assume that that point is halfway in between those two numbers. So when points have decimal value, my stomach is growling, or when there's no graph. Okay, if you don't have a provided graph, yes, you would use slope formula, or you use slope formula whenever there's a decimal value. Do not, this one, it was okay to assume that just because they actually give us the point, but they won't always label those 2 points. So if it's not a good point, then don't do it. Don't use it. Okay. Or pick your other point. Pick another point that actually works for you. Okay. All right, your turn to practice.